have been looking at unit rates, ratios, proportions. Today we're going to kind of put all of that together. Specifically today we're going to look at how unit rates can be represented on graphs, how you can find unit rates on graphs, and we're also going to look at turning a ratio table into a graph and what that's going to look like. So let's start with looking at a unit rate on a graph. Something to remember, unit rate means how much for one. So for this example, you could do either the number of points per game or you could do the number of games per point. Think about which one you think makes more sense and why you would choose that one. All right, now that you've given that a little thought, remember when we talked about unit rates, we talked about if you set them up in a bridge map or something like that, then you want to put the bigger number on top. So if I look at this, I'm going to see that points has my bigger numbers than games. So it sort of makes more sense to do points per game. You could do games per point, that would work, but it makes more sense to do points per game since it has the bigger numbers. So now let's take a look at that. If we want to know the number of points per game, one way we could find it, and really the easiest way to find it, is by finding one game, because remember unit rate means how much for one. And if we go up to the line, right here's a point that's on the line for one game, and then come across to the y-axis, and we see that one game and 20 points are an ordered pair. So what that means is that our unit rate is 20 points per game. Now, let's look at another example. Take a moment to see if you can find the unit rate for this one. All right, now that you've tried this, if you look, it makes the most sense to say we're looking for the number of dollars per hour because dollars has the bigger numbers. So if we look at hours, we want to find 1 hour and how many dollars goes with it. Well, 2 is right here, so we need to go back, and we can see that 1 is right along this grid line then. And if we go up that line, and then we find the point where it meets where the ratio is graphed, and go across to the axis, that number has to be 30 because it's on a grid line, and that's halfway between 0 and the next line, that's 60. So we would say the unit rate here is $30 per hour. Pause for a minute and see if you can figure out this one. All right, now that you've had a chance to look at it, when I look at this one, we're going to do the number of sit-ups per minute. Well, you could do minutes per sit-up, but it probably makes more sense to do sit-ups per minute because sit-ups have the bigger number. But when we look at this, where 1 would be for the number of minutes, if we try to go up that line and across, we're not exactly on one of the grid lines, so that's really not the most reliable way to do it probably. So I would say look at the 2 and say, well, in 2 minutes, we can do 40 sit-ups. So if I set that up on a bridge map, we're looking at the number of sit-ups per minute, and the relationship that we know is that we can do 40 sit-ups in 2 minutes. What we want to know is how many sit-ups can we do in 1 minute? Well, 2 divided by 2 is 1, so 40 divided by 2 is 20. We can do 20 sit-ups per minute. And really, that would work with any ordered pair that we chose or any point that was on the graph. For example, if I looked at in 4 minutes, we can do 80 sit-ups. That would still work over here because if I put 40 sit-ups, or excuse me, not 40, but 80 sit-ups, 80 sit-ups in 4 minutes, and how many sit-ups in 1 minute, then when I divide by 4 on the bottom and the top, I'm still going to get 20 sit-ups per minute, or 20 sit-ups in 1 minute. Now this one's a slightly more challenging one because you got to look a little closer. Take a look and see if you can figure this one out. All right, now that you've had a chance to look at this, hopefully you're looking at gallons per hour. If we try to find how many gallons in 1 hour, well, if this is 3, then this is halfway between 0 and 3. This is at 1.5 hours. Does that help us find the unit rate? Not really. Not to mention the fact that we really can't go across to the axis and read that number very well. So we need to look for a point that is on the grid lines, on those gray lines that you see in the background. So I might look, for example, at this point, or maybe at this point. I can choose either of those. It doesn't matter which one I choose. If you want to choose this one, simply because it has both the x and the y-axis labeled with numbers there, you could do that. So if I look at that, I'm looking at the number of gallons per hour. And when I look at that, it's 120 gallons in 12 hours. And the unit rate means I want to know how many gallons in 1 hour. So I can divide 12 by 12 and 120 divided by 12, and I'm going to get 10. So my answer is, or my unit rate is 10 gallons per hour. So now that we've had a chance to see what a unit rate looks like on a graph, how we can find it, let's take a look at some ratio tables and then using those both to make a graph and to find the unit rate. So let's look at an example up here. So our first example, a tomato plant produces an average of 20 tomatoes in 5 weeks. So if I want to fill in the missing numbers on this ratio table, I can look at it and say, well, 20 tomatoes in 5 weeks. Definitely my first number is going to be right there. So when I look at that one, then I can figure out my other numbers a variety of ways. One way I could do it is I could say, well, what I see is that the number of tomatoes per week, and I could do weeks per tomato, it doesn't matter, I just put the tomatoes on top because they have the bigger number, is 20 tomatoes in 5 weeks. So if I come up and I want to use this to solve this line right here, then I'm going to say, well, that's how many tomatoes, because that's what I don't know in that pair, in 1 week. And I can do both of those divided by 5, and that's going to give me 4 tomatoes in 1 week. Once I know that, the others become pretty easy to solve, because I can set that up as, well, if I can have 4 tomatoes in 1 week, then how many tomatoes, or 12 tomatoes rather, would take how many weeks? So I could look at this and say, I could use cross products if I wanted to, or I might say, well, 4 times 3 is 12. So I could do 1 times 3. It must take 3 weeks to grow 12 tomatoes. And I can use that same bridge map to do my last row there. If I can get 4 tomatoes in 1 week, then in 9 weeks, how many tomatoes am I going to have? And using the bridge map, I can see that I'm going to have 36 tomatoes. And my unit rate, I actually can see pretty easily from this bridge map actually, is 4 tomatoes per week. Now, although it isn't a focus of this lesson, we also could look at this and pick out the independent and dependent variables in this situation. The independent variable in this situation, the thing that has to happen in order for the other one to happen is there has to be time in order for the tomatoes to grow. Therefore, the number of weeks is our independent variable, and our dependent variable is going to be the number of tomatoes. Now, one more thing to do, and that's to graph this. So when we graph this, again, all of this table, all the ratio tables, the function tables, the variable or independent and dependent variables, the unit rates, all of this kind of ties together. You could even look at this ratio table, and some of you might be looking at it and saying, well, can I not do this as x for weeks and y equals 4x? Well, yeah, you can. That relationship does exist. For every week, there are 4 tomatoes. So there are 4 times as many tomatoes as there are weeks. When we graph that relationship, we're going to come over here and try to decide how is it that we want to graph it. Well, on the x-axis is where we're going to put our number of weeks. So let's start by putting weeks here as our label. And then we need to decide what to count by. Well, our greatest number of weeks is 9, and there's 12 boxes across here. So we can just do 1 week in each grid line. So 0 would be at the origin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And my tomatoes are going to go along my y-axis, the number of tomatoes. And the greatest number of tomatoes is 36. Well, I have 16 boxes high, or 16 lines high. So I could count by 2s. I'm not quite going to fit that last one on there, but that's okay because it's close enough. I can probably get a pretty good idea of where it's going to belong by looking at my other points. So if I count by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32. And then when I go to graph my ordered pairs, I'm going to show that in 1 week I can have, or I will have, 4 tomatoes. In 3 weeks, I will have 12 tomatoes. In 5 weeks, I will have 20 tomatoes. And in 9 weeks, I will have 36 tomatoes. And that one doesn't quite fit on the grid, but it looks like we're on the graph, but it looks like it should be somewhere right about there probably. And if I actually go and graph this, I'm going to find out, in fact, I did a pretty good job probably of placing that because my line goes through that point. So every point or every pair, ordered pair, whatnot, that we can make, every equivalent ratio that we can make that is equal to a ratio of 20 tomatoes in 5 weeks is going to fall on that line. All right, let's look at one more example of this. A recipe calls for 5 cups of flour for every 2 eggs. So I should be able to say, well, I know if there's 2 eggs, there has to be 5 cups of flour. Now I can use the bridge maps to solve this ratio table just like I did the last one. But I want to show you another way you could do this. Now if I were going to set up a bridge map, I would set it up as the ratio of eggs to flour, or flour to eggs. It doesn't really matter. And 2 to 5 is that ratio. And then on this line right here, to solve this, I want to know how many eggs for 20 cups of flour. And I should be able to see, or you should be able to see, I can do 5 times 4 to get 20. And 2 times 4 then is 8. But you don't necessarily have to do all that. If you can look and see, well, the 2 numbers that I knew were I had 5 cups of flour, and I wanted to find out how many eggs for 20 cups of flour. Well, in going from 5 to 20, I used 4 times as much flour. If I use 4 times as much flour, then I also need, you guessed it, 4 times as many eggs. So I can do 2 times 4 to get that 8 that belongs there. You could do that way. I can do, if I wanted to, I could use bridge maps for all of these, but I could continue to use relationships that I can see in order to finish this ratio table. For example, if I use 6 eggs, that's 3 times as many as using 2 eggs. Therefore, I would need to use 3 times as much flour. I would need 15 cups. If I wanted to use 35 cups of flour, that is 7 times as much as 5 cups of flour, and therefore I would need to use 7 times as many eggs as 2. So I would need 14 eggs. If I want to find the unit rate for this one, it's a little harder because there's no 1 anywhere in our ratio table. So we don't see how much for 1. So your bigger numbers are your cups of flour, so you might want to put that on the top. It's up to you. I think it makes it a little easier. And then your number of eggs we could put on the bottom. So the ratio we know is 5 cups of flour for 2 eggs. What we want to know is how many cups of flour for 1 egg. So when we solve that, we're going to do 2 divided by 2 to get 1 egg, and 5 divided by 2 is going to give us 2 1/2 or 5 halves or 2 1/2 or 2 5/10 eggs, or 2 1/2 cups of flour rather. So the unit rate is 2 1/2 cups of flour per egg. Now, last but not least, we want to graph this. And when we do that, along our x-axis, we're going to put the number of eggs. And along the y-axis, we're going to put the cups of flour. So when we go to label this, the greatest number of eggs we have is 14. Well, we have 12 lines here, so we get pretty close to that with counting by ones. So we can just leave that last ordered pair off. As long as we get 3 of them on, 3 out of 4, that's pretty good. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And going up, we're going to do the cups of flour. And we want to go pretty close to 35, get as close as we can. But when we look, since there's 16 boxes or 16 lines going up, we're going to get really close by counting by 2s, because 16 times 2 is 32. We can go as high as that. And again, that just leaves that last ordered pair off. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32. The only step left now is the graphing. So when we go to graph this, for 2 eggs, we need 5 cups of flour. So we go to 2 eggs and 5 cups of flour. Well, now 5 cups of flour is not going to be here at 4, and it's not going to be here at 6. It's going to be halfway in between those. So it's going to be right about here. Then I have 8 eggs and 20 cups of flour. So 8 eggs on the x-axis and go to 20 cups of flour on the y-axis. Is going to put us right about there. 6 eggs requires 15 cups of flour. So 6 eggs, and then I'm going to go up to 15. It's right about there. And for 14 eggs, remember I couldn't quite fit that on my grid, but if I could have, it would have still been in a straight line with these ordered pairs or these points. And when I draw the line that goes through those points, it's going to go right about there. All right. So now, interestingly enough, if you look at this, we can also see the unit rate. If you look very carefully, where we can at least see that our unit rate makes sense. Here's 1 egg, and if we go up from 1 egg, just a little bit above the 2 cups of flour, because we're right about here. So that makes sense that we're at about 2 1/2 cups of flour. Hopefully, taking a look at this has given you a better understanding of how ratios, ratio tables, proportions, unit rates, the graphs, all of that stuff goes together in different ways you can work with them.